While Washington is pouring hundreds of billions of dollars into the F-47 and the B-21, a different stealth duo is quietly being built in Beijing with one clear ambition: to shatter every American planning assumption over the Pacific. J-36, a rumored sixth-generation stealth fighter designed to act as the brain that commands an entire swarm of drones, and H-20, a long-range stealth bomber, advertised as being able to strike American base clusters and radar networks from Alaska all the way to Hawaii. If these two platforms can actually do what China is hinting at, then the entire air defense playbook of the United States and its allies over the coming years may have to be rewritten from scratch. In this episode, we are going to dig into two simple questions that are very hard to answer. First, what exactly are the J-36 and the H-20? What missions were they designed for inside China's warfighting doctrine? What technologies are they trying to bring to the table in stealth, radar, sensors, weapons, and combat radius? From satellite images, sketches, leaks, and Western analysis, how much of the real picture can we piece together? Second, how dangerous are they really? Are the J-36 and H-20 strong enough that the United States and its allies will be forced to treat them as a serious challenger in the fight for air control? Strong enough that planners in Washington, Tokyo, and Canberra have to rewrite air defense and air campaign plans for the next decade. If you want to understand Beijing's real ambition behind this J-36 and H-20 pairing, stay with us all the way through this episode. If you want to keep watching how these machines shift the global balance of power, hit subscribe and turn on notifications so you do not miss the next deep dive. What sixth generation really is, and why China chose this path. There is no NATO textbook that says, quote, "This is the official standard for sixth-generation fighters." Instead, the big air forces, United States, Europe, Japan, China, are all staring at the same picture. Fifth-generation jets like the F-22, F-35, and J-20 will not be good enough in two critical jobs: surviving inside extremely dense A2/AD defenses and fighting while controlling an entire web of sensors, drones, and long-range weapons around them. Put simply, fifth generation was the era of the stealth jet that takes care of itself. Sixth generation is the era of the aircraft as the brain of an entire flock flying around it. If you boil it down, most sixth-generation concepts orbit the same hard pillars. First, the aircraft is no longer fighting alone. It is one node in a network. It has to talk to satellites, ground sensors, warships, and, most importantly, a pack of loyal combat drones flying with it. Second, you need real artificial intelligence and true data fusion. The system has to pull and filter data from radar, electro-optical sensors, and the digital battlefield. Then give the crew a clear, simple picture instead of drowning them in a dozen separate screens. Third, stealth is no longer just about radar cross-section. It is about infrared signature, about how hard you are to see when jamming is everywhere and cyber attacks are hitting your links. And fourth, range and payload have to be large enough to stay outside the wall of enemy air defenses, while still reaching in with long-range missiles. That means sixth generation is not simply about flying faster, climbing higher, or pulling tighter turns. In fact, American studies say classic dogfights, two jets turning in circles trying to get on each other's tail, will keep shrinking. The real stage will be beyond visual range, where everything is radar, sensors, and data links. That is why American and European companies talk so much about digital engineering, designing the jet fully in the digital world from day one, about open architecture so you can swap software and sensors fast, about variable cycle engines that sip fuel in cruise, yet unleash power when you need to sprint, and even about directed energy weapons like lasers to shoot down incoming threats at close range. Inside that picture, the J-36 is Beijing's answer to the question, what is sixth generation, done in their own style? While the United States leans toward an F-47 that looks more like a traditional stealth fighter with very powerful AI, Chengdu is sketching something closer to an airborne cruiser. A blended wing body, no tail surfaces, 3 engines, a side-by-side 2-seat cockpit, and a weapons bay long enough to swallow ultra-long-range missiles. Why 2 people sitting side by side under that huge canopy, even though many analysts say that hurts stealth? Because China's view of sixth generation is brutally pragmatic. In the next 10 to 15 years, AI will not be trusted enough to fully replace humans in the decision to fire or not fire. But the sheer volume of information on the battlefield is already beyond what one pilot can truly manage. Their solution is simple: split the job. One person in the left seat focuses on flying, survival, and the main senses. The other, the systems officer, focuses on controlling the drone swarm, picking targets and assigning weapons. If you think about it, this is the Chinese flavor of the same idea the US Air Force calls CCA, Collaborative Combat Aircraft. Uncrewed combat jets that fly along, taking orders from a manned mothership. The J-36, with its large size, 3 engines for more power and range, and 2-seat cockpit for higher task capacity, is designed to be that mothership. It does not need to dive deep into a wall of Patriot, Aegis, and THAAD batteries. It can stay outside, use all-aspect stealth to stay hard to lock, and then push its drones and extreme-range missiles forward to do the dirty work. On the American side, the F-47 is moving in a similar direction. Next-generation stealth, heavy sensors, and links to an entire flock of CCA drones on its wings. The difference is in the trade-offs. Washington is trying to keep the airframe as clean as possible. Single seat, smaller canopy, and let AI and software architecture carry more of the burden. Beijing is willing to sacrifice some pure geometric stealth with that big canopy and side-by-side seating in exchange for a second human brain in the loop. And this is where it gets interesting. When you look at the J-36, you are not just looking at a strange 3-engine jet. You are looking straight at how Beijing sees sixth-generation warfare. Put humans in the role of orchestral conductor over a swarm of autonomous aircraft and design the platform around a doctrine of system versus system. You do not just try to win a duel against one enemy jet. You try to break their entire web of sensors, command nodes, and logistics. Once you understand that, the next question comes naturally. How exactly is the J-36 being built to play this role of flying brain? And how much will it really force an American pilot in an F-47 to worry? That is where we go next. Chengdu J-36, China's airborne cruiser. Now let us put the spotlight on the first main character, Chengdu J-36. If you look at a top-down shot of the J-36 for just a second, it almost looks like a gigantic ginkgo leaf. The body and wing are almost one single slab, the leading edges broken into diamond and double delta angles, no vertical tail like an F-15 or Su-35, and 3 engine nozzles packed tightly together in the back. This is not some stylistic choice to look cool. It is a cold-blooded decision. Prioritize all aspect stealth and speed plus range plus endurance, not airshow-style aerobatics. Geometrically, the blended wing body, the multiple broken edges, no tailplane, no canards, no vertical fins, all of it serves one purpose: strip down the number of hard edges that radar can see, especially at lower frequencies. The main edges on the J-36 are aligned so they are either parallel or perpendicular to each other, the same trick the Americans used on the F-117, the B-2, and the F-22. The J-36 also uses sawtooth weapon bay doors, tight-fitting panels, electro-optical sensors buried into the skin, and joints covered with soft materials to cut reflections. In other words, this is not a cheap copy of 5th generation. It is a serious attempt to touch the next tier of stealth. The 3 engines are not there just to show off. One of the biggest bottlenecks in next-generation warfare is electrical power. Stronger sensors, larger active electronically scanned array radars, high-bandwidth data links, even directed energy weapons if they appear, all of them drink electricity like water. With 3 engines, the J-36 buys 2 things: extra thrust for supercruise, flying supersonic without afterburner, and extra megawatts to feed a whole forest of electronics, radar, data links, and possibly large electronic warfare pods. The trade-off is obvious. The aircraft gets bigger, heavier, and more complex. But for China, a few large platforms that can stay on station for a long time and control a wide formation of unmanned systems fit their geography better than a swarm of small fighters that must depend on forward bases. What really makes analysts sit down and start sketching, though, is not just the shape. It is the role the Chinese Air Force is hinting at: an airborne cruiser. When you have an airframe big enough to carry a weapons bay on the order of 7 to 8 meters, what can you do with it? First option, you cram it full of very long-range air-to-air missiles like the PL-17, and you use the J-36 as a sniper platform to hunt enemy early warning aircraft, tankers, and command jets from standoff distance. Second option, you load long-range cruise missiles for land and maritime strike, so the J-36 can hit surface targets without ever closing in. Third option, you combine both. The J-36 fights and kills on its own, while at the same time commanding a swarm of drones and missiles flying alongside. In reality, the J-36 is still in the test phase. The photos we have show prototypes with rough edges, engine shrouds not fully finished, intakes still being tweaked, landing gear layouts changing from one test flight to the next. There is zero public proof that it has reached anything close to the stealth level and reliability of an F-22 or F-35, let alone a future F-47. But for force planners, the mere fact that such a prototype exists, has flown multiple times, and has been allowed to show up at China's own version of Area 51 is enough to change the question in their reports. It is no longer, when will China get a 6th generation platform? It becomes, how many years do we have before the J-36 reaches an initial combat-capable state? And that is only half the story. The other half is this: how does a flying brain like the J-36 plug into a strategic punch that reaches across oceans? Put simply, when you place the J-36 next to the Xian H-20, how dangerous does the full picture of Chinese air power start to look? In the next part, we will drop down a little lower onto those long tracks that start deep inside mainland China and stretch out over the sea. Tracks where a stealth bomber crosses into a pre-planned kill zone, calmly drops its weapons on target, and then vanishes back into the dark. The main character there is the H-20. Xian H-20, the punch from the dark. If the J-36 is the brain in the sky, then the H-20 is the fist that brain sends into the dark. And to understand the H-20, you have to go back to a very boring-sounding name: Xian Aircraft. This is the factory that used to survive by assembling and upgrading the H-6, which is essentially the old Soviet Tu-16. Over time, they learned how to stretch the life of that airframe to an almost absurd level. From a bomber born in the 1950s, they turned it into a launch platform for cruise missiles that can fly farther, hit more precisely, and push China's strike radius well beyond its coastline. The same Xian plant is also where the Y-20 was born, a heavy, four-engine transport that looks clumsy but marks a very important milestone. For the first time, China designed and built a large military transport aircraft without directly copying a Russian frame. That was the dress rehearsal. The H-20 is the next step on that road, and the jump is much bigger. Instead of a traditional tube fuselage with wings, the H-20 is described as a stealth strategic bomber with a blended body and wing in the same family as the B-2 and the B-21. The idea is simple and brutal. A bomber takes off from deep inside mainland China, flies thousands of kilometers out into the Pacific, carries cruise missiles or glide bombs, hits bases like Guam or critical infrastructure targets, then turns around and goes home without ever needing to skim along the enemy coastline. With range that Pentagon reports estimate at more than 6,200 miles, roughly 10,000 kilometers, and the option for aerial refueling, the H-20 on paper can reach Hawaii or even farther. But flying wing stealth is not a playground for beginners. Even for the United States, bringing the B-2 into real service took decades of testing, mistakes, redesigns, and mind-blowing investment in materials, radar-absorbent coatings, and maintenance routines so complex that every B-2 sortie is practically a full-scale engineering operation. China is trying to compress that journey. They lean heavily on simulation, digital design, and the experience they gained as a supplier for Boeing and Airbus. But between a clean model in a wind tunnel and a real aircraft weighing hundreds of tons flying in the open sky, there is always a brutal gap. The leaked images, propaganda models, and CGI clips show an H-20 with the familiar flying wing outline, intakes on the upper surface to hide the engine fans from radar, a big weapons bay in the belly, a smooth, flat profile with very few protrusions. However, unlike the J-36, there is still no clear, confirmed imagery of a real H-20 in flight. Only a few blurry videos and vague articles hinting at a first test. Even American intelligence officials, when asked, usually answer in extremely careful language. China is clearly pushing this program hard, but the distance between a prototype and a full squadron of H-20 ready to carry real bombs across the Pacific is an entirely different story. Here is where the questions American viewers care about split into two layers. The first layer is technical. Can the H-20 ever reach a stealth level that is good enough to slip through the radar belts around Guam or Hawaii? Public Pentagon reports repeatedly mention Chinese struggles with radar-absorbent materials, with the manufacturing precision needed for stealth skin panels, and with maintaining a smooth, tightly sealed flying wing surface on a large airframe. Even if they solve that, the next question is reliability. An intercontinental bombing run has no room for cascading failures, from engines to power systems, from cabin pressurization to navigation. The second layer is human. The United States does not just have B-2 and B-21 airframes. It has 3 decades of operational experience with stealth bomber fleets, training pilots, planning missions, maintaining the jets, and building entire base infrastructures that can hide and support these fragile assets. China is stepping into this world almost from zero. Its Air Force has never run a real long-range bombing campaign like Kosovo, Iraq, or Afghanistan. So the question is not only can the H-20 reach Guam, it is, would Beijing really risk sending a strategic crown jewel into airspace saturated with American sensors in a real shooting war? And yet, if you cling to those doubts and conclude that the H-20 is not worth worrying about, that is probably a little too comforting. Even if, in its first decade, the H-20 only achieves 2/3 of what U.S. planners fear, it still creates a very real strategic psychological effect. For the first time, American rear area bases in the Pacific would have to account for the possibility of being hit by a stealth platform flying in from very far away. Not just by ballistic missiles or cruise missiles launched from ships and ground launchers. That alone forces the United States to disperse forces, thicken defensive rings, split up ammo depots and fuel farms. All of that adds up to massive long-term cost. Put the H-20 next to the B-21 Raider, and the difference in philosophy becomes clear. The B-21 is the product of a stealth ecosystem that has matured. It focuses on cost-effectiveness, easier maintenance, and a modular design that can be upgraded for decades. The H-20, at least on paper, looks more like a statement. China wants to push its punch beyond the second island chain and even reach targets that used to be reachable only by ballistic missiles. One side is optimizing a capability it already dominates. The other is announcing its arrival in a tiny club where so far only the United States truly operates. What makes this story even tighter is that you cannot look at any one aircraft in isolation. The H-20 is not designed to fly alone like a Cold War B-52. In many future war concepts discussed by Chinese analysts and Western observers, the H-20 moves undercover, an outer ring of stealth fighters like the J-20, another ring of J-36 aircraft managing drone swarms. All of that backed by long-range surface-based air defense and radar networks on the ground. In that setup, the H-20 is not just a bomber. It is the core of a complex strike package built on stealth, range, and psychological pressure. Which means the real American question is not simply, is the H-20 equal to the B-21? It is this. When the J-36 and the H-20 start appearing on the same map, how will that force the United States to redraw its base layout, its logistics lines, and its deployment plans across the Pacific? In the next part, we will lock those two puzzle pieces together and look at the bigger picture Beijing is trying to paint. J-20 holding the near fight, J-36 directing drone swarms further out, H-20 throwing the deepest punch. And all of them together posing an entirely new kind of problem for the F-47 and the B-21. When the J-36 and H-20 meet the F-47 and B-21. Look at the paper specs, and it is tempting to turn this into a simple scorecard. J-36 versus F-47, H-20 versus B-21. Add up the numbers and declare a winner. Reality is much messier. The United States and China are not just building two pairs of aircraft. They are building two different answers to the same problem. How do you keep air superiority and deep strike in a battle space flooded with radar, missiles, electronic warfare, and drones? On the American side, the F-47 inside the NGAD program is the next step in the logic of the F-22 and F-35. A compact airframe with very high stealth, a single pilot in the cockpit, and behind that one human, a powerful stack of artificial intelligence and open software architecture to carry the mental load. The F-47 does not fly alone. It moves with a pack of collaborative combat aircraft, CCA, uncrewed fighters that can carry sensors, missiles, or jamming gear. The B-21 Raider is a different story. It is a stealth platform tuned for long-term efficiency. The United States learned some very painful lessons from the insane cost of the B-2. So the B-21 was designed from day one to be easier to build, easier to maintain, and simple to upgrade by swapping sensors, software, and weapons without throwing away the airframe. In plain language, the B-21 is both a strategic weapon and a carefully engineered industrial product. In the eyes of American planners, the real concern is not that China will suddenly unveil perfect clones of the F-47 or B-21. It is that their versions, even with flaws, can be good enough to make defense far more expensive. The J-36 does not have to match F-47 stealth. It only has to be hard enough to see and smart enough to run a large swarm of cheaper drones. The H-20 does not have to hit every performance line next to the B-21. It only needs enough range and enough stealth to force Guam and Hawaii to spend billions more on radar, missiles, hardened shelters, and dispersed ammo and fuel. Seen from Beijing, the pressure runs in the other direction. The F-47 and B-21 are a constant reminder that if China does not accelerate, the generational gap will open again, just like it did with the F-22. When Washington openly says that F-47 prototypes are flying and that B-21 is moving into deployment, the message is loud and clear. Speed up, accept risky designs like the J-36, pour resources into the H-20, or get left behind. That is why China has a reason to push the J-36 out in the open early, even with rough edges, and to let images leak as proof to both domestic audiences and rivals that they are still in the race. At the same time, the United States is spreading its attention across Europe, the Middle East, and the Indo-Pacific, while China can focus most of its air power industrial effort on a single theater, the Western Pacific. In that narrow arena, every step forward for J-20, J-36, and H-20 turns directly into extra risk for American bases, warships, and supply lines. The race is not just about speed or range anymore. It is about who can build a system of systems faster, smarter, and tougher to break. So we arrive at the hard question. If you were sitting in a Pentagon war room tonight, what would you change first to deal with this new triad of Chinese power in the Pacific? The aircraft, the bases, or the entire strategy? This is Future War Tech. We will see you in the next episode.